students, welcome to the world of chemistry. Chapter 4, Chemical Bonding and Molecular Structure. This is the e-content lesson number 6. Students, you have learned the previous e-content lessons. Learn well. In this section, we can learn about an important topic, the bond parameters, lattice enthalpy and resonance. First, we begin with the bond parameters. What is bond parameters? Have you heard the term bond parameter? Bond parameter refers to the characterization of covalent bond on the basis of various parameters like bond length, bond order, bond angle and bond enthalpy. Students, what is bond length? Can you define the term bond length? Bond length is defined as the equilibrium distance between the centers of nuclei of two bonded atoms in a molecule, and bond length is measured in picometer or Armstrong unit. Students, see the slide. What is the bond angle of methane CH4? Is it 90 degree or some other bond angle? See the slide. The bond angle of methane is 109 degree 28 minutes. So, this geometry, the 4 bond pairs of methane is in minimum repulsion. Can you define the term bond angle? It is defined as the average angle between the lanes representing the orbital containing the bonding electrons. Students, what is bond enthalpy? Can you define the term bond enthalpy? It is defined as the energy required to break one molecule of a particular kind of bond in a molecule. That is the average energy required to break one mole of particular kind of bond in a molecule. What about the bond enthalpy of hydrogen molecule? The bond enthalpy of hydrogen molecule is 435.8 kilojoule per mole. See the equation. Hydrogen gas gives hydrogen gas plus H gas, that is H2 gas gives H gas plus H gas. Delta H is 435.8 kilojoule per mole. Then students, what is bond order? Can you define the term bond order? Bond order gives the number of covalent bond in a molecule. What about the bond order of hydrogen molecule? Yes, bond order of hydrogen molecule is 1, that is it contains one covalent bond, that is a single bond. Bond order of oxygen is 2, that is it contains two covalent bond or double bond. What about the bond order of nitrogen? Bond order of nitrogen is 3, that is it contains 3 covalent bond or triple bond. Can you give the equation of bond order? Bond order is equal to half into Nb minus Na. What is Nb? Number of electron in bonding molecular orbital. And what is Na? Number of electron in anti-bonding molecular orbital. That is, bond order is equal to half into BMO minus AMO, where BMO is the number of electron in bonding molecular orbital and AMO is the number of electron in anti-bonding molecular orbital. Then students, can you define the term bond order? Yes, bond order is defined as the half the difference between the number of electron in bonding molecular orbital and number of electron in anti-bonding molecular orbital. Students, can you give the significance of bond order? The first significance is the positive value. Bond order has positive value, the molecule is stable. What about the negative or 0 value the bond order has? Negative or 0 value of bond order indicate the molecule is unstable. And second, the bond order is directly proportional to bond enthalpy or bond dissociation energy. That is, bond order increases, bond dissociation energy also increases. And third significance is bond order is inversely proportional to bond length. That is, bond order increases, bond length decreases. And fourth significance is bond order is fractional value. If the bond order is fractional value, the molecule is definitely paramagnetic. That is, it contains the number of unpaired electrons. And the fifth significance is the bond order values is 1, 2, 3, etc. It refers to bond order 1 means single bond, bond order 2 means double bond, bond order 3 means triple bond. These are the significance of bond order. Students, what are the factors depend on bond length? The bond length depend on the nature of atom and type of bond between the atoms. Example, carbon-carbon single bond length is 154 pm. In ethane, CS3 single bond CS3. In carbon-carbon double bond, the bond length is 134 pm. In ethene, CS2 double bond CS2. In C triple bond C, the bond length is 120 pm. In ethane, that is in acetylene, CH triple bond CH. Next factors depend on bond length, that is bond length decrease with increase in multiplicity of the bond, that is double or triple bond. Bond length is found to increase in the size of atom in a molecule. Then we pass on to lattice enthalpy. What is lattice enthalpy? Can you define the term lattice enthalpy? It is defined as the amount of energy released when 1 mole of ionic solid is formed by close packing of gaseous ions. Can you give the example of ionic solid? Sodium chloride. That is example sodium chloride. Na plus gaseous and Cl minus gaseous forms 1 mole of sodium chloride by releasing lattice energy, that is represented by the letter U. That is Na plus gaseous plus Cl minus gaseous gives 1 mole NaCl plus U, where U is the lattice enthalpy. Yes, students, define lattice enthalpy. What is lattice enthalpy? Lattice enthalpy is defined as the amount of energy released when 1 mole of ionic solid is formed by close packing of its gaseous ions. Students, then the next important term, resonance. What is resonance? Can you define the term resonance? When a molecule cannot be represented by a single structure, but its characteristic properties can be described by 2 or more structures, then the actual molecule is said to have the resonant hybrid of following structures. Can you give an example for resonance? Yes, ozone molecule, O3. Students, see the slide, the structure of ozone. Give the characteristics of resonance. Resonance will shorten the bond length. Resonance will stabilize a molecule. The number of unpaired and paired electron remains the same. Energy of action molecule will be less than the energy of the stabilized of the contributing structures. This difference is called resonance energy. Then students, we can do an assignment. Calculate the bond length of HCl. The given data, the bond length of HH is 74 pm, the bond length of CaCl is 198 pm. That is RHH is equal to 74 pm, RClCl is equal to 198 pm. Then bond length of HCl is equal to RHCl is equal to half into RHH plus RClCl is equal to half into 74 plus 198 pm is equal to 136 pm. That is the bond length of HCl. Students, in this Ekendall lesson, we learn about the bond parameters like bond length, bond order, bond angle, bond enthalpy, then lattice enthalpy and resonance. Thank you students, learn well. We will meet the next Ekendall lesson number 7. Thank you.